Okay, calculus, let's do one that has 3 variables so we can see how this works. And it'll be largely similar, only we'll have 3 equations to work with. It's going to be a fun time. So find the minimum value of f of x, y, z equals 2x squared plus y squared plus 3z squared subject to the constraint 2x minus 3y minus 4z equals 49. So let's do our partials. F of x, f of y, f of z. These are 4x, 2y, and 6z. What about our partials with respect to our g partials? G of x, g of y, g of z. It's 2 lambda. I'm going to go ahead and multiply it in. Negative 3 lambda and negative 4 lambda. So my 4 equations are 4x equals 2 lambda, 2y equals negative 3 lambda, 6z equals negative 4 lambda, and what's last, we get, if we need it, the 2x minus 3y minus 4z equals 49. How do we normally solve a system of 3 equations with 3 variables? The first thing is supposed to be eliminate one of the variables, so you can get it down to 2 equations with 2 variables. I am going to try to... Actually, the best way maybe right now is going to say, let's solve for lambda here. We get lambda equals 2x, and substitute it in for the other 2. So we get 2y equals negative 6x. We get 6z equals negative 8x. Which means y is negative 3x, and z is negative 4/3 x. What this is going to allow me to do is plug in all of these values into my constraint function to figure out at least what x is, and then I can just go from there because I have equations for y and z in terms of x. So we have 2x minus 3 times negative 3x minus 4 times negative 4/3 x equals 49. So that's 2x plus, it looks like 9x, looks like plus 16/3 x equals 49. That's 11x plus 16/3 x equals 49. I'm just going to multiply by 3 here. So 33x plus 16x equals 147. So that's 49x equals 147. So x is 3. Now for the rest of my equations, we know y equals negative 3x. So y is negative 3 times 3, which is negative 9. Z is negative 4/3 times x, which is negative 4/3 times 3, so that's negative 4. So my 3 values are 3, negative 9, and negative 4. Now, what does that mean? Well, let's plug in and see. It wants the minimum value of the function, so again, f of x, y, z equals 2 times 3 squared plus negative 9 squared plus 3 times negative 4 squared, which is 18 plus 81 plus, looks like 48, which is also 147. Now, the question is, does that minimize the value? Well, if we're not sure, why don't we try another value just to make sure? You want it to be higher, so let's see. We could let x, y, and z be in the hundreds, and then when we square them, they'd be gigantic. So I think this is a safe bet that the minimum of f of x, y, z subject to g of x, y, z is 147. And we will do number 5 in the next video.